So this is the specimen material for Unit 2 for the AS Chemistry. I'm going to try uploading it in 3 parts this time because I've been having real problems uploading it with sound on the iPad. Some sort of technical issue, I don't know. If you hear a strange noise in the background, that's my dog panting. If I leave the room, she whinges, so we're stuck with that noise, I'm afraid. So here we go. Question 1. The enthalpy change for the formation of ammonia is minus 46.2 kilojoules per mole. What's the enthalpy change in kilojoules for the reaction? And you'll see there it's 2NH3 gives you N2 and 3H2. And I've pre-filled this so that it just is a bit quicker when I'm doing it, okay? So when we look at this, we'll see that the enthalpy change for formation of ammonia, which is going in the direction of this arrow, is minus 46.2. So when we're going in the direction of the other arrow for this reaction from ammonia to its elements, we'll have to change the sign. So there are 2 moles of ammonia here. So 2 times 46.2 is 92.4, which is answer C. Then the next question, how many structural isomers of C4H10 exist? Well, there's one where you have a 4 carbon chain and then one where you have a 3 carbon chain with a methyl group attached to it. So the answer there is A. And in 3, a radical is a particle with an unpaired electron. That should be a no-brainer for you. A particle with a negative charge or a positive charge are ions, and something with a lone pair of electrons is just something with a lone pair of electrons. So the answer there is A. Which of the following molecules has the highest boiling point? Well, if we look at A, that's an alkene, and D is an alkane. So we know that they just have van der Waals. With C, we have this chloromethane. So it will have permanent dipoles, but the holy grail here is the ethanol with the hydrogen bonding. And we know that hydrogen bonds are the strongest intermolecular forces, so it's going to have the highest boiling point. So the answer there is B. Okay, question 5. Which of the following isomeric alcohols is resistant to oxidation? So immediately we're looking for something which is tertiary. So we can rule out the pentan 1-ol and pentan 2-ol because you know they're just straight chain molecules. So pentan 1-ol will be primary, pentan 2-ol will be secondary. And that leaves us with A and B, which I've drawn out here. So A is at the top. And you see when that structure is drawn out, the OH group is attached to the first carbon and it's only attached to one other carbon, so it's primary. And in B, the OH group here is attached to a carbon which has 2 other carbons attached to it, which makes it tertiary, so the answer is B. And it's useful to be able to rule things out pretty quickly, so if you're going to draw structures, you're only doing a couple of structures. Number 6, which of the following has a higher thermal stability than strontium carbonate? So I've written here group 2, going down the group, beryllium, magnesium, calcium, strontium and barium. We know that thermal stability increases down the group, so the one with the higher thermal stability has to be below strontium, and that makes it barium carbonate, which is answer A. In the next question, what volume of oxygen is required for the complete combustion of 100 cubic centimetres of butane at room temperature and pressure? So we start by writing out the balanced equation. So butane is C4H10, which means we have 4 carbon dioxide and 5 water being formed. So the number of oxygens here from the carbon dioxide is 8, and we have another 5 here, so that gives us 13. So it's 6.5 O2. We know because it's looking for a volume of gas that it's just a simple ratio. So 100 then to 650. If it was 1, it would be 6.5. So you're just multiplying up. So the answer there is C, 650. Question 8, the reaction between ethene molecules is described as, well, we know that ethene has a double bond in the middle, so if you're reacting many of those molecules together, it's polymerization. And number 9, it's talking about standard conditions when calculating enthalpy changes. Now this is different from the standard conditions or the standard temperature for gas volume, which is 273. So it's actually D, 100 kilopascals and 298 Kelvin. You might be tempted to go for B, but it's not correct. So which of the following decreases as group 2 is descended from magnesium to barium? So that's going down the group. So atomic radius actually goes up, or sorry, goes down, as atomic radius goes up as you go down the group, so it increases first ionization energy as the outer electron gets further away from the nucleus, will decrease, need less energy to remove it. The reactivity in water increases down the group, and the solubility of the hydroxides also increases. So the answer there is B, first ionization energy. So if you want to see the rest of the questions, I will upload 2 more parts, one with question 11, 12 and 13, and one with 14, 15 and 16.